Hey everyone, welcome to this comprehensive guide on NEET UG Chemistry. The NEET UG exam is your ticket to a medical career in India. It's a crucial step for anyone aspiring to become a doctor, dentist, or any other healthcare professional. It's tough, and chemistry is a big part of it. Chemistry isn't just about memorizing equations and reactions, it's about understanding the principles that govern the natural world. This video breaks down the chemistry syllabus, making it super easy to understand. We'll cover everything from the basics to the more complex topics, ensuring you have a solid foundation. We'll explore the important ideas, words, and topics you need to know, from atomic structure to chemical bonding, and from thermodynamics to organic chemistry. We've got you covered. Think of this video as your map to the huge world of chemistry. The periodic table, chemical reactions, and lab experiments will all become much clearer. Like a telescope helps us see faraway galaxies, this guide will help you navigate tricky chemical reactions, atomic structures, and the cool world of molecules. You'll learn how to approach problems methodically and think like a chemist. So buckle up because we're starting an exciting journey. This isn't just about passing an exam, it's about gaining knowledge that will be useful throughout your medical career. This isn't just an exam, it's your first step to a great career in healthcare. Understanding chemistry will help you in various fields, from pharmacology to pathology. By learning these ideas, you're not just memorizing facts, you're learning the language of life itself. Let's get started, dive deep, stay curious, and remember, every great doctor started right where you are now. Chemistry is the study of stuff, called matter, and what it's like. It explores the properties, composition, and structure of substances, and the changes they undergo during chemical reactions. Matter is anything that takes up space and has weight. This includes everything around us, from the air we breathe to the ground we walk on. It comes in different forms: solid, liquid, and gas. Solids have a definite shape and volume, liquids have a definite volume, but take the shape of their container, and gases fill the entire space available to them. Dalton's atomic theory is a really important idea. Proposed by John Dalton in the early 19th century, it laid the foundation for our understanding of matter. It says all matter is made of tiny pieces called atoms. These atoms are the smallest units of chemical elements and retain the properties of the element. Atoms of the same element are the same, while atoms of different elements are different. For example, all carbon atoms are identical, but they are different from oxygen atoms. Chemical reactions happen when atoms rearrange. During these reactions, the bonds between atoms are broken and new bonds are formed, creating new substances. The law of conservation of mass says matter can't be created or destroyed in a chemical reaction. This means the total mass of reactants equals the total mass of products. The mole concept is super important for chemistry math. It allows chemists to count atoms and molecules in a given sample by relating the mass of a substance to the number of particles it contains. A mole is a way to measure how much of a substance we have. 1 mole contains exactly 6.022 x 10 circumflex 23 particles, known as Avogadro's number. It's like saying a dozen, but for atoms and molecules. Just as a dozen means 12 items, a mole means 6.022 x 10 circumflex 23 particles, making it a fundamental concept in chemistry. Atoms aren't the smallest things. They're made of even smaller bits: protons, neutrons, and electrons. Protons are positive, neutrons have no charge, and electrons are negative. Light travels in waves. The photoelectric effect showed that light can also act like tiny particles called photons. The Bohr model shows how an atom is built. It says electrons circle the nucleus in specific energy levels. When an electron jumps from a high energy level to a low one, it gives off light. Understanding how atoms are built is key to understanding how they bond and how elements behave. Atoms stick together to make molecules. There are 2 main ways they stick: ionic and covalent bonds. Ionic bonds happen when one atom gives an electron to another. This creates ions, which are charged atoms. Opposites attract, forming the bond. Covalent bonds happen when atoms share electrons. This type of bond is common in organic molecules. VSEPR theory helps us guess the shapes of molecules based on the electrons around the central atom. A molecule's shape affects what it can do. Section 5. Energy in chemical reactions. This section delves into the fascinating world of how energy is involved in chemical reactions, a fundamental concept in chemistry. Thermodynamics studies how energy changes in chemical reactions. It helps us understand the energy flow and transformation during these reactions, which is crucial for predicting reaction behavior. Energy can change forms, but can't be created or destroyed. This principle, known as the conservation of energy, is a cornerstone of physics and chemistry. That's the first law of thermodynamics. It tells us that the total energy of an isolated system remains constant, though it can change forms. Enthalpy, or H, is the heat in something at constant pressure. It's a measure of the total energy of a thermodynamic system, including internal energy and the energy required to make room for it by displacing its environment. The change in enthalpy, delta H, tells us if heat is released, exothermic, or absorbed, endothermic. This is vital for understanding reaction energetics and predicting whether a reaction will release or absorb energy. Entropy, or S, measures disorder or randomness. In any spontaneous process, the total entropy of the system and its surroundings always increases. The second law says the universe's entropy always increases in spontaneous processes. This law explains why certain processes occur naturally and why energy tends to disperse. Gibbs free energy, or G, combines enthalpy and entropy to tell us if a reaction will happen on its own. It's a crucial concept for predicting the spontaneity of chemical reactions. A negative delta G means it will. This indicates that the reaction is spontaneous and can proceed without any additional energy input. Section 6. Solutions and their properties. A solution is a well-mixed combination of substances. The bigger part is the solvent, the smaller part is the solute. Concentration tells us how much solute is dissolved. We use molarity, M, molality, M, and parts per million, ppm. Raoult's law says a solution's vapor pressure is lower than the pure solvents. This affects boiling and freezing points. Colligative properties depend only on the number of solute particles, not what they are. These include boiling point elevation, freezing point depression, and osmotic pressure. Section 7. Chemical equilibrium, a balancing act. Chemical reactions are often reversible, going both ways. Chemical equilibrium is when the forward and reverse reaction rates are equal. The equilibrium constant, Kc, shows the amounts of reactants and products at equilibrium. A big Kc means the reaction favors products. Le Chatelier's principle says if a system at equilibrium is changed, it will try to undo the change. Things that affect equilibrium include concentration, pressure, and temperature. Section 8. Redox reactions and electrochemistry. Redox reactions involve electron transfer. Oxidation is losing electrons, reduction is gaining them. Electrochemistry studies chemical reactions and electrical energy. Electrochemical cells convert chemical energy to electrical energy and vice versa. Standard electrode potential, E degree, measures a half cell's tendency to be reduced. The Nernst equation relates cell potential, E, to standard cell potential and concentrations. Section 9. The speed of chemical reactions. Chemical kinetics studies how fast reactions go. The rate is the change in concentration over time. Many things affect reaction rates: concentration, temperature, surface area, and catalysts. Collision theory explains how reactions happen. Molecules must collide with enough energy, activation energy, and the right way. Rate laws show the relationship between rate and reactant concentrations. Reaction order tells us how rate depends on each reactant's concentration. Section 10. Exploring the world of inorganic chemistry. Inorganic chemistry studies elements and their compounds except most carbon ones. The periodic table organizes elements by atomic number and properties. Elements in the same group, column, have similar properties. The P block has nonmetals, metalloids, and some metals. The D block has transition metals and the F block has lanthanides and actinides. Coordination compounds have a metal ion bonded to ligands. Ligands are molecules or ions that give electrons to the metal ion. Section 11. Understanding organic chemistry. Organic chemistry focuses on carbon compounds. Carbon can make 4 bonds, creating tons of molecules. Purification techniques are used to isolate and clean organic compounds. Common methods are crystallization, distillation, and chromatography. Hydrocarbons are organic compounds with only carbon and hydrogen. They can be alkenes, alkynes, or aromatic. Organic compounds with halogens, oxygen, and nitrogen have lots of different properties and are important in biology. Section 12. Conclusion: your journey to success. We've explored the huge NEET UG chemistry syllabus. We looked at matter, atoms, and chemical reactions. Remember, NEET UG's success needs deep understanding, not just memorizing. Keep asking questions, find resources, and practice hard. Like an astronomer looking at stars, be curious and eager to learn. The world of chemistry is waiting. Good luck on your NEET UG journey.